We're fortunate to have Kevin King from USDA ARS for the last two systems. Thanks, Kevin.
All right. So the slides here, I'm going to go through these that Stan created, but we use this same type of system, and that's the inline flow monitoring, the Signature Series flow meter. They used to be, ISCO had a 2150 area velocity sensor. They have now switched that, so it's a simultaneous multi-sensor. You can connect 9 devices to that. So what you're seeing is this is the acoustic Doppler velocity transducer. It is quite expensive, as configured above with the associated cables, and then in the Cedar Creek watershed where Stan is working, they also implement a Palmer bolus flume. So the whole system is looking at it right at $7,000 to install this. So just looking at it's very similar to what Shinhua just talked about. The area velocity sensor, it will measure in both the positive and negative directions. It does have a level transducer as recorded by a pressure transducer, which, as you can imagine, does not like freezing conditions. And similar to what we just heard from Shinhua, we do have a minimum depth of 1 inch, or otherwise no velocity is recorded. Our experience is it generally works better under cloudy or aerated water, but we have started to see and been working with ISCO to make it more sensitive. We have some pretty clean water in cases, and we are still seeing some pretty good results. The transducer, the level part of this, we don't see any drift at all. We're actually measuring in our work here in Ohio. We're using 2 different measurements, and we do not see any drift in that transducer. The unfortunate thing is these are not repairable. They are a sealed system. They do have to be sent back to the manufacturer for repair if something does go awry. They are very good for submerged flow conditions, which as we get into the second talk here, we'll be able to see that that's how we are using them. So here's a schematic of the system that was installed in the Cedar Creek watershed in northeastern Indiana. They have a 6-inch pipe, PVC pipe coming in, and that connects into the Palmer bolus flume, and then exits out into a 6-inch pipe. So there is they have a bubbler there that they're recording. So this one, in this particular case, they're using a bubbler rather than the area velocity sensor. But in some of the other pipes that they do have the area velocity sensor back in, and well, that is it over in the left-hand side there before it drops into the Palmer bolus flume. They are measuring. That's where the AV sensor is located. So at the site, in order to set these up, it does require pretty extensive earthwork in order to get that done. You can see that in this site, they're using an insulated heated enclosure so that they don't have to worry about those freezing conditions and can collect all year. It's adaptable to both solar or landline power. Most everything that Stan is using there and what we are using is solar power. We very rarely have power drops. They are connected, and they're using this to drive their automated samplers. They have ISCO samplers connected to these, and they, on a weekly or for sure event basis, is when they are visiting the site. And they also have everything collected to a telemetry network, and they're able to dial in and see if the system is working properly. So the key points for this type of system, initially that data logger setup is kind of intimidating. This is a new system that ISCO has just come out with in the last 6 months. The nice thing is that you can, though, put 9 different devices on it. That could be another type of a level logger. You got the area velocity sensor. You could put a bubbler on that. You could put a pH meter, some type of any other type of logging type instruments that you wanted. You can plug into this system. Although it's not plug and play, you do have to program specifically for those types of instruments that you're going to put in. It does not require a separate computer to either program or download the data. You can do that. You can do that just with a thumb drive in most of these systems now. The AV sensor, it's good for both high and reverse flow, as Jane talked about. We have measured that. We have seen negative velocities as well when a ditch will fill up and we'll get water going back into a pipe. So the AV sensor, again, it works best in cloudy and aerated conditions, but we've got some pretty clear systems, and we feel like we're getting some pretty reliable data from that as well. We do have to have 1 inch of water in order to get a positive or a reliable velocity reading, which means we're eliminating all those low flows. So that is one drawback. The bubbler, the depth itself is accurate at plus or minus 2 millimeters. And then so the low flows then are handled by the Palmer bolus flume. And then the AV sensor is handling the larger flows.